October 2025. An interstellar visitor is passing through our solar system right now. And what it's doing is making scientists recalculate everything they thought they knew about comets from beyond the stars. This is 3I Atlas, the third confirmed interstellar object in human history, and it's leaking water like a fire hose at full blast. Not close to the sun, where you'd expect it, but roughly 3 times farther from the sun than Earth. In temperatures so cold that ordinary comets should be completely dormant. NASA's Neil Gehrels Swift Observatory detected it first. The James Webb Space Telescope confirmed it. Independent observatories worldwide are watching it unfold in real time. And what they're finding doesn't match Oumuamua, doesn't match 2I Borisov. This is something else entirely. I'm going to give you the official data, the water loss rate that's breaking all the models, the chemistry that proves this comet formed around another star, and what this tells us about water and life-related compounds across the galaxy. Comment below, what do you think this comet can teach us about planetary systems beyond our own? Let's go. This isn't clickbait. This is happening above your head at this exact moment. An object moving at 31 kilometers per second through the region beyond Mars's orbit. Speed fast enough to escape our sun's gravitational pull forever. A trajectory that screams foreign registry. This object doesn't belong to our solar system. Never has, never will. Subscribe if you want moment-by-moment updates as new data drops, because this one is big, scientifically, historically, and yes, emotionally. The detection came from the ATLAS survey system. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, operated by the University of Hawaii and funded by NASA's Planetary Defense Program. In December 2024, ATLAS detected a fast-moving object. Within days, orbital calculations performed by NASA's Jet Propulsion Laboratory and the Minor Planet Center confirmed something extraordinary. The comet's eccentricity exceeds 1.0, clear evidence that it came from interstellar space and will never return after it departs the sun's gravitational field. Right out of the gate, it earned the 3I tag. That I is crucial. It stands for interstellar. Third, confirmed interstellar object ever detected after 1I Oumuamua in 2017 and 2I Borisov in 2019. That I means everything. It means the orbit isn't an ellipse bound to the sun like every comet and asteroid we've studied for centuries. It's a hyperbola, a one-way track, a cosmic encounter we can study for months before it vanishes into deep space forever. Let me repeat something because it's almost impossible to comprehend. This object has been traveling through the galaxy for millions, possibly hundreds of millions of years. That's not just astronomy news. That's a Rosetta Stone from another star system moving with the clockwork precision of celestial mechanics passing through our neighborhood right now. The phrase cosmic time capsule isn't mine. It's coming directly from research teams analyzing this visitor. They didn't just observe this object, they're reconstructing its journey across the Milky Way, star by star, gravitational pull by gravitational pull, trying to figure out where it came from and what it's made of. You tell me what it means. Before we go any deeper, let's address the elephant in the room. Is this thing going to hit us? No, absolutely not. Everyone breathe. The closest approach to Earth happens in the coming months, and we're talking about a distance measured in hundreds of millions of kilometers. No impact threat, no extinction event. No last night on Earth playlist needed. This is a flyby with benefits. A safe, bright, analyzable lab sample, a messenger from another star drifting close enough for our instruments to harvest its secrets, then sailing on into the cosmic void forever. But here's what makes this flyby so valuable. It's close enough to study in unprecedented detail, close enough for every major telescope on Earth to point at it, close enough for spectroscopy, polarization analysis, composition studies, far enough to be completely harmless. This is the Goldilocks zone for scientific discovery. Now, let me give you the hard data, the timeline, the specifics. Detection: December 2024, Atlas Survey System. Classification: Interstellar Comet, third of its kind ever. At discovery, its inbound velocity relative to the Sun was measured at approximately 31 kilometers per second, comparable to other known interstellar visitors. Current position: moving through the outer planetary region. Visibility: observable through early 2026 as it moves into deep space. The safe distance never changes. The scientific opportunity only grows. Here's where things get mind-bending. Interstellar objects are original recipe. They preserve chemical fingerprints and mineral structures from the protoplanetary disks where they formed. Not our protoplanetary disk, not our Sun's disk. Other protoplanetary disks under other stars, in other radiation fields, at other temperatures and pressures. Think of it as exoplanetary DNA. You sample it, you read it, you reconstruct the story of worlds that never orbited our Sunday. That's not science fiction, that's spectroscopy. Subscribe now. The shock line comes next. In early 2025, NASA's Neil Gehrels Swift Observatory turned its ultraviolet eye on 3I Atlas. What they detected stopped everyone cold. Hydroxyl emissions, OH molecules. That's the signature of water molecules breaking apart under ultraviolet radiation. Now, you might be thinking, comets release water all the time. That's what they do. And you'd be right, except for one problem. 3I Atlas was roughly 3 times farther from the Sun than Earth when this activity was detected. At that distance, solar radiation is weak. The surface temperature should be far too cold for water ice to sublimate in measurable quantities. Yet 3I Atlas was releasing water anyway. Let me give you the numbers, because the numbers are what make this impossible to ignore. Researchers estimate that 3I Atlas is losing water at a rate of approximately 40 kilograms per second. That's comparable to a fire hose at full blast, 40 kilograms every single second. Not close to the Sun, where solar heating could explain it. But deep in the outer solar system, where physics says this shouldn't be happening, comment below. What do you think could drive water loss at 40 kilograms per second so far from the Sun? Multiple research teams, including work utilizing observatories worldwide, are confirming this object originated far beyond our solar system. The trajectory reconstruction backs it up. Over millions of years, stars jostle comets. Giant planets kick fragments clean out of their cradles. Most fall silent in the dark. A few, very few, wander into the glare of alien suns. This is one of the few. Comment: how many more are out there that we haven't detected yet? Now let's talk chemistry, because this is where the story gets weird. The James Webb Space Telescope turned its infrared eye on this visitor, and early analysis suggests something unusual. Chemical signatures that don't perfectly match either Oumuamua or 2I Borisov. Spectral data showing compounds that indicate this object may have formed in a very different stellar environment than our own Sunday. Here's the bombshell. Studies with the James Webb Space Telescope found that the coma of 3I Atlas is unusually rich in carbon dioxide. The carbon dioxide to water ratio is far higher than what we typically see in solar system comets, way higher. That difference is significant because it points to a different origin or structure, different formation conditions, different stellar environment, different chemistry. The chemical signatures suggest it formed farther out, colder, or under a different stellar radiation environment. Maybe it formed around a cooler star. Maybe it formed in a disk that had different elemental abundances from the start. This is the chemical dialect of another system. We're hearing an accent in frozen compounds that doesn't belong to our family tree. What kind of star system do you think created this object? Drop your theory below. Think about the implications. Really think about them. Somewhere, tens of millions of years ago, maybe hundreds of millions, a giant planet in a distant system nudged a small cold body out of its natal path. It wandered through interstellar night longer than mammals have been mammals. It passed stars we've never named through darkness we'll never see. And in 2025, it drifted into our light long enough for teams worldwide to measure its trajectory, analyze its chemistry, and call it what it is, a capsule from deep time. Here's what makes the latest space update so significant. 3I Atlas is brighter than expected for an object of its estimated size. The brightness profile doesn't match standard models for either asteroids or comets. When scientists look at the spectra, they're seeing absorption lines that require explanation. They're seeing brightness variations over time that suggest something is happening on or near its surface. Unlike 2I Borisov, which displayed clear cometary activity with a visible tail, 3I Atlas shows a different pattern. It's releasing water at extraordinary rates, yes, but its overall behavior doesn't match what we've seen before. Yet unlike Oumuamua, which appeared completely inert, 3I Atlas displays activity that suggests it's not entirely dormant. What we're witnessing could be slow sublimation of exotic ices, compounds that evaporate at different temperatures than water ice. Or it could be internal processes we don't fully understand yet. Chemical reactions, phase transitions, mechanisms that don't require direct solar heating. The point is, we don't have a complete explanation. And that's actually exciting because it means we're seeing something genuinely new. Now let's talk about what NASA isn't saying and why. Here's the reality in scientific discovery, especially regarding astronomy news of this magnitude. There's a crucial difference between not saying and not yet confirming. When teams detect something unusual, the process is rigorous. Multiple independent observations are required. Data must be peer-reviewed. Models need to be tested and retested. With 3I Atlas, they're being careful. According to sources familiar with the ongoing NASA research process, there are several aspects still under intense analysis. First, exact size and shape remain uncertain. Current estimates place it somewhere between several hundred meters and over a kilometer in diameter. But without a resolved image, scientists are working with light curves and brightness models. Second, the question of origin. Backtracking an interstellar object's trajectory is extraordinarily complex. Gravitational perturbations from countless stars over millions of years make precise origin determination nearly impossible. Scientists can narrow down the general region of space it came from, but pinpointing the specific star system requires assumptions about travel time and stellar positions millions of years in the past. Third, ongoing observations from multiple facilities are looking at 3I Atlas, not just in visible light, but in infrared, ultraviolet, and even radio frequencies. Some of this data is still being processed. Some requires months of analysis. That's not secrecy, that's science. When Oumuamua passed through in 2017, scientists observed it accelerating slightly as it moved away from the Sunday. That tiny acceleration sparked massive debate. The debate continues to this day because we didn't have enough data. NASA and ESA don't want that to happen again. With 3I Atlas, they're coordinating a global effort. Multiple observatories, multiple wavelengths, multiple techniques, all aimed at extracting every possible piece of information before this visitor fades from view. Here's what's confirmed as of this latest NASA Discovery update. 3I Atlas is real, verified, definitely interstellar. Its trajectory has been calculated and confirmed by multiple independent teams. Its brightness and spectral characteristics place it in a category distinct from both previous interstellar visitors. It poses zero threat to Earth. It will remain observable for months. What's not yet confirmed is mostly what they genuinely don't know. The specific star system of origin, the exact formation mechanism, the complete compositional analysis, the full explanation for its unusual water loss rate at such large heliocentric distance. These aren't secrets being withheld. They're puzzles still being solved. Every interstellar visitor is a sample from another star system. a place we cannot reach with current technology. These objects carry chemical and physical signatures of alien stellar environments. Planetary systems we may never directly observe. If 3I Atlas is a fragment from a planetary system around another star, perhaps ejected during planet formation or a catastrophic collision, then its composition tells us about the building blocks available in that system. We're reading the biography of a solar system we'll never see, written in ice and rock that traveled across the galaxy to reach us. And here's why this matters beyond just one comet. Because 3I Atlas is only the third confirmed interstellar object ever observed, its unusual chemistry and behavior provide a rare window into how planet-building materials might vary across the galaxy. The high carbon dioxide ratio, the extraordinary water loss rate, the chemical signatures that don't match solar system comets, all of this tells us something profound. Water and other life-related compounds might be more common beyond our solar system than we once thought. The ingredients for life, frozen in comets, wandering between stars, distributed across the galaxy. The detection of 3I Atlas following Oumuamua and 2I Borisov confirms something remarkable. Interstellar objects passing through our solar system aren't rare cosmic flukes, they're regular visitors. Statistical models suggest that at any given moment, there may be an interstellar object somewhere in our solar system. Most are too small or too faint to detect with current instruments. But as our asteroid discovery capabilities improve, we'll spot more. The Vera Rubin Observatory will revolutionize this field, allowing astronomers to detect interstellar visitors earlier and track them longer. Multiple space agencies are now studying the feasibility of rapid response missions, spacecraft that could be launched on short notice to rendezvous with an interstellar visitor, providing close-up data impossible to obtain from Earth. Imagine sending a probe that could actually match velocity with an interstellar object. We could take high-resolution images, sample its surface directly, capture water vapor, analyze the chemistry in ways we can't from Earth. That would transform interstellar science from remote observation to in situ exploration. That's the goal. That's what comes next. Let me be absolutely clear. 3I Atlas is not a threat. It's not artificial. It's not a probe. It's a natural object following the laws of physics through a hyperbolic orbit. The reason NASA isn't saying certain things isn't because they're hiding alien contact. It's because they're doing science properly, gathering data, running models, waiting for peer review. But I understand why people wonder, because deep down we want to know, are we alone? 3I Atlas won't answer that directly, but it will teach us about planetary system formation, about the diversity of chemical environments around other stars, about the galactic neighborhood we inhabit, about how water, the essential ingredient for life as we know it, exists across the galaxy, frozen in comets, wandering between stars, maybe seeding worlds we'll never visit. Here's where we are right now, in late 2025. Telescopes are tracking, spectrometers are analyzing, scientists are collaborating across continents. Every night that weather permits, someone somewhere is pointing an instrument at 3I Atlas, gathering photons, recording spectra, building the data set that will be analyzed for years to come. We are witnessing a moment in astronomical history, the age when interstellar visitors transform from theoretical possibilities to observed reality. When the space between stars becomes not an impenetrable void, but a highway carrying messages from distant worlds. 3I Atlas is such a message, and we're learning to read it. In short, this comet is rewriting the rule book on what we expect from visitors from other stars. Leaking water in deep space at 40 kilograms per second. Behaving differently to familiar comets, carrying chemistry that formed around another sun, and reminding us that the cosmos still holds far more variety than we have imagined. For now, the latest space update is this. 3I Atlas is out there, real, confirmed, interstellar, moving through our solar system on a trajectory that will never repeat. A once-in-a-generation cosmic encounter we can study for weeks. Comment below. What do you think is the most important thing we should learn from this interstellar visitor before it leaves our solar system forever? Subscribe for updates as the story develops, because this is happening now, above your head, this exact moment. A cosmic time capsule crossing through our neighborhood, carrying secrets from another world, leaking water where no water should flow, teaching us that the ingredients for life might be more common across the galaxy than we ever dared to imagine. Let's keep watching.